Okay, so I was saying we have to know the conversion factor of the gram to kilogram and the conversion factor of the cubic centimeter to what? To the cubic meter. So we know for the gram and the kilogram, we know that 1,000 grams is the same as 1 kg. Okay, but do we know how many of these make these or how many of these make these? No. So what are we going to use there? We are going to use congruence. Okay, congruence, similarity and congruence. We had such a topic in grade 10, right? Yeah, so we're going to use that. So this is centimeter, this is meter, and then we are just adding a cubic. So from what we know, we can get what we don't know, okay? So I'm going to write this. We know that 1 meter is equals to what, guys? Is equals to how many centimeters? Is equals to 100 centimeters, right? Okay, so from this 1 meter is equals to 100 centimeters, we can get what 1 cubic centimeters is equal to. So what are we going to do here? We're just going to say this side, let me what? Cube it. Even this side, let me what? Cube it. So if you cube something, it means this power will go to the 1 and then it will go to the m. So 1 multiplied by 1 multiplied by 1, it still gives you what? 1. And then m multiplied by m multiplied by m, it gives you m to the power 3. Then this is equals to, okay, here, this power 3 goes to the 100. And then again, this power 3 goes to the what? To the centimeters here. Okay, so what are we going to have? We are going to have 100 to the power 3, and then centimeter to the power 3. So what is 100 to the power 3? Okay, so we are multiplying 100 by itself 3 times. So you can just click on your punch on your calculator. So 100 multiplied by 100 multiplied by 100. Or you can just do 100 to the power 3. So 100 to the power 3 gives me what? Okay, so let me. Okay, 100 to the power 3 gives me a median. Okay, a median is just what? 10 to the power 6. But anyway, let's just write it. So a median is something that has 6 zeros, right? Okay, so your calculator will give you this value. So 100 to the power 3 is going to give you this, and then cubic centimeters like that. So it means 1 cubic meter is equals to what? 1 million cubic centimeters. So it means this is a conversion factor, this one here. This is a conversion factor we are looking for, okay? This guy here. So I'm going to write it here, just down here. I'm going to wrap some of the things here. Okay, and then I write that conversion factor. Okay, so that conversion factor that we've found by ourselves said 1 million, okay, cubic centimeters is the same as 1 cubic meter. Okay, so now we have the conversion factor of this to that, and the conversion factor of this to this. So we can convert them now. Okay, we can convert them now. So this is what we are going to do, guys. Okay, this is what we are going to do. I'm going to write 1 grams, and then I'm going to divide by centimeter cubic. Okay, so this is the same as 1 gram per cubic centimeter like this. If you want, you can write it like that. Okay, and then from here, I'm going to multiply by those conversion factors that we found. Okay, so I'm first starting with the ones for what? For the grams. Okay, so I'm going to say multiplied by, and then I'm going to draw a line here. So as I said, I'm going to start for the one for the grams, right? So if you have your gram on top there, okay, then you want your gram here to be down so that the gram and the gram here will cancel. So we have 1,000 grams, okay, being equal to what? 1 kg. And then multiplied by, now we put the one for what here? For the volume. Okay, so since I have cubic centimeters down here, I want my cubic centimeters to be on top here. So I'm going to say 1 million here, okay? 1 million cubic centimeters. And then down here, I'm going to put what? 1 meter cubed. So you've seen what I've done here. So this, what I've done here is what you call dimensional analysis in chemistry. Okay, just canceling out units. Okay, but in physics, dimensional analysis, it will be checking the correctness of the formulas, something like that. Okay, but in chemistry, when they say dimensional analysis, this is what they mean. They just want you to cancel out units. Okay, by this method that I've used. So from here, okay, my network now. From here, we can see that this gram and this gram is going to do what? To cancel. This cubic centimeter and this cubic centimeter is going to cancel. So what are we going to remain with? We are going to remain with 1 multiplied by 1 kg multiplied by what? 1 million. So that's what I'm going to write here. So I'll write 1 multiplied by 1 multiplied by 1 million. Okay, 1 million, then I'll put the kg at the end. And then I'm dividing all this by what? 1,000 multiplied by 1 cubic meter. So I'm going to write 1,000 multiplied by 1 cubic meter. Okay, and then from here, it's just a matter of canceling. We can see that the ones are just, they are making no difference, okay? Because if you multiply anything by 1 itself. So we can just cancel out some of the zeros. So these zeros go, and then I cancel out with those zeros. Okay, so what do I remain with on top here? 1 multiplied by 1 multiplied by a 1,000. So I'm going to remain with the 1,000 what? Kilogram. And then I'm dividing all this by 1 multiplied by cubic meter. So I can write just cubic meter. And we see that this here is the same as 1,000 kgs per what? Meter cubic. So we have converted that 1 gram per centimeter cubic to this. Okay, so any questions now on how we have done that? Feel free to ask.
So my question, as in it's not part of this, but as in on the questions, not on the question that you're from solving, but I wanted to ask, are they like stages? Let's say if they're giving marks, are they following certain stages? Or you can skip where we have like 1 multiplied by 1 multiplied by something.
Yeah,
So
yeah.
can you skip that stage?
Yeah, you can skip some of those.
Oh,
I was just showing
right.
all of it so that you don't get lost, but you can skip some.
Okay.
Okay, so that's how you do that one. Let's look at another one. So here we have 0.5 decimeter cubic, and then they're asking us to change it to what? They're asking us to change it to a liter. Okay, so this one here is a simple one. Okay, why is it a simple one? Because, okay, why is it a simple one? It's because a liter is the same as a cubic, a cubic decimeter. Okay, a liter is the same as a cubic decimeter. So what do I mean? 1 cubic decimeter like this is the same as 1 liter. Okay, so this is the simplest question here. So how do you convert 0.5 cubic decimeters to liters? It will just be the same 0.5 liters. Okay, well, because their relationship is being shared by this conversion factor. Okay, so you can put your 0.5 down here. Okay, and then you say equals to x, and then you cross multiply, this x will still be 0.5. Okay, so know that. Okay, sometimes when you reach the part for calculating the molarities, the what, okay, sometimes they don't give you liters, they just give you cubic decimeters. So you have to know in your head that cubic decimeters is the same as a liter. Okay, okay, and then the next one again is also the same, it's simple. Okay, so milliliter is the same as cubic centimeter. Okay, who was making this question? Okay, so milliliter, this guy here, is the same as this guy. So it means that 1 milliliter is the same as 1 cubic centimeter. Okay, so they're asking us to convert 500 milliliters to cubic centimeters. So the answer there will still be 500 cubic centimeters. Okay, so know this relationship when you're dealing with the volume. These are very common relationships. You have to know them by heart. Okay, 1 milliliter is equals to 1 cubic centimeter, and 1 liter is the same as 1 cubic decimeter. Okay, and then here we have volume. I've shown you how to calculate volume, right? Yeah, so this one, you can solve it and you can share your solutions in the group, okay? Otherwise, I'm going to go to question 8. Okay, so question 8 says, which of the following represents the smallest mass? Okay, so what do we notice here? We notice that all these masses have been given in different units. Okay, but they are all masses, but they have been given in what? Different units. So we have centigram, this is centigram, we have microgram, we have milligram, we have gram itself, and then we have kilogram. Okay, so how do you determine which one is the smallest mass? You have to change all these guys to what? To the same units. And then after changing to the same units, now you can compare them. Because the way they are here, you can't compare them because they're in different units. So it means we have to change this guy to grams, change this guy to grams, change this guy to grams. This one is already in grams. And then we also have to change this guy to grams. And these are very easy to change to grams because we can use the what? The metric system. Okay. So let's convert them. So let's come on the board here. So the first one there is 23 centigrams. Okay. So 23 centigrams is what in grams? Okay. We are just going to endelea discuss C. Okay. And say what is its value in the metric system? Okay. What's the value of a cent? Anyone who remembers? What's the value of a cent in the metric system? Forgotten. It's 10 to the power what?
Cents is 100.
It's 100.
10 to the power negative 2.
Yes, okay, it's 10 to the power negative 2. So wherever there's a cent there, we're just going to put 10 to the power negative 2. Okay, so this will be 23 multiplied by, where there's cent, we are going to put 10 to the power negative 2. And then we say grams. Okay, so if you want, you can punch this into your calculator. Okay, let me try. So 23 multiplied by 10 to the power minus 2. It's giving me what? Okay, it's giving me 0.23 grams. Okay, so we've changed this to grams, and then the next one we had what was that? I've forgotten. Okay, 2.3 multiplied by 10 to the power 3 micrograms. Okay, so let's put it here. 2.3 multiplied by 10 to the power minus 3, and then micrograms. So let's change this to grams. Okay, so we're just going to use the metric system. What is the value of the micro here? The value of the micro is 10 to the power what? 6. So this will be 2.3 multiplied by 10 to the power minus 3, then multiplied by, where there's micro here, we know that micro is 10 to the what? Power minus 6, and then grams. Okay, so we see that this and this are the same base, right? So we can add their powers. So this will be 2.3 multiplied by 10 to the power minus 9 grams. Okay, and then from here, let's convert the other one. So the other one was the 0.23 milligrams. Okay, so very easy to convert. We're just going to attack this milli. Okay, so we know that milli is just 10 to the power minus 3. Okay, so familiarize yourself with the metric system. So this would be 23 multiplied by 10 to the power minus 3 grams. And then this is equals to, we can put this in Okay, I think let's put all of them in scientific notation so that we can compare them easily. Okay, so this is 23, so it means the point is there. So if I move this point one step to the left so that it comes there, so that it comes 2.3, okay? It means I'll have to multiply by 10, okay? It will be times 10 to the power what? So I've moved to the left, so it will be 10 to the power 1. And then multiplied by that 10 to the power minus 3, okay? And then grams. So this and this have the same base. So we can add 1 and this minus 3. We're going to get what? A minus 2. Okay, so I moved where? I moved to the right, right? I moved to the left, I mean. So this power has to be a positive power. Okay. Yeah, so if I add this and this, I'm going to get 10 to the power what? Okay, I think I made a mistake somewhere. Yeah, I've seen the mistake here. So this one here, I looked at it. I have 0.23, but I took it as a 23. So it has made everything here wrong. So no, whatever I was doing there is not the correct thing. So here we have, let me write what we have now. We have 0.23. So it should be like this. And then we want to make this greater than 1. So we are moving now this guy one step to the right. So we have 2.3 multiplied by 10 to the power minus 1, because we have moved one step to the right, and then multiplied by 10 to the power minus 3, and then grams. So we see that this and this are the same, so we can add the powers. So what are we going to have there? 2.3 multiplied by 10 to the power minus 4, right? Okay. So if you have any questions, you can ask. So this would be 10 to the power minus 4, and then grams. And then the other one is already in grams. Okay, let me just write it here. The other one was already in grams. We are given 0.23 grams in the question. Let me confirm. Yeah, this one here. Okay, and then we are left with the last one here. So in this one, we have a kilo there. So what is a kilo? A kilo is 10 to the power 3. Okay, so let's replace that into the equation. So we have the last one. Okay, I'll write it here. For the last one, we have 2.3 multiplied by 10 to the power minus 2 kg. Okay, we want to change this to a gram. So this kilo here, we said is what? 10 to the power 3. So this and this space are the same, so we can add minus 2 and 3. What is minus 2 plus 3? It will be 1. Okay, so it means our final answer will just be 2.3 multiplied by 10 and then grams. Okay, so now we have these 4 numbers here. Which one is the smallest? Which one do you think is the smallest? We have this one, this one, this one, and this one, and even this one here. So which one do you think is the smallest, guys, among those numbers? Which one is the smallest?
I think the one which is on number 2, the 2.3 times 10 to the power negative 9.
Yes, okay, so that's correct. Okay, so the one on B here is the smallest because it has the highest negative power there. It's 2.3 multiplied by 10 to the power minus 9. Okay, so we can conclude that the smallest, okay, will just be equals to 2.3 multiplied by 10 to the power minus 9 grams, which was on B. Okay, so that's how you solve that one. So any questions there? Okay, I presume there are no questions. It means we've come to the end of our class. And there's a bonus question here. Okay, there's a bonus question here. They're saying distinguish between exact and measured numbers. Okay, so exact numbers. Okay, these are just numbers that are obtained by counting. Okay, so if, for example, you have 5 pens in your hands and then you count them 1, 2, 3, 4, 5. That's an exact number. It means you have exactly 5 pens. Okay, but measured numbers are numbers obtained through measurements. So you can use a meter rule, you can use a beam balance, okay, to measure something. You can use a thermometer, okay. All those are measured numbers because you are using an instrument to what? To measure them. But the exact numbers are just numbers that you obtain by counting, or numbers that have or numbers that are in a fixed definition. Okay, so for example, we know that 1 dozen. Okay, some people say dozen. Okay, so 1 dozen is equals to what? Okay, when they say 1 dozen, what do they mean?
They mean 12.
Yes, 12. Okay, so 1 dozen is an exact number because it means exactly 12. Okay, so numbers that are in fixed definitions or numbers that you obtain by counting are what we call as exact numbers. And then measured numbers, these are numbers obtained through measurement using a specific what? Instrument. Okay, so that was the lesson for today. Unless you guys have other questions. Okay, so that's where the lesson will end for today. But before you go, I want to show you guys something. Okay, I want you guys to see something. So just a minute, I show you. Okay, so I want to show you the drive for those who are not familiar with the drive. Okay, I want to show you the drive. So where is it? It's here. Okay, so on this drive, if you want to learn in advance, okay, you can start learning because there are a lot of videos that we did for the previous intakes and the like. Okay, so if you want to learn in advance, you can just go there and you will start learning. Okay, so I'll go in this folder here, and then I'll go in that folder. So I shared this link in the group. I don't know if you guys saw it. So we have 4 courses there that we offer. So there's math, physics, whatever. Okay, so you can go in any subject that you want among these 4. So if, for example, you go in chemistry there, you'll find these 6 folders there. Okay, so in here we have the lessons and tutorials. Here we have well summarized handwritten notes. Okay, and then here that's where we put like the tutorial sheets. Okay, and then here we have the past papers. Okay, so we put the tutorial sheet that we solve here, and then here we put the past papers, and then there we have lab report samples, and then here we have just general university data. Okay, so if, for example, I go into these lessons here, you will see that I'll find different folders for different what? Topics. Okay, so for those who want to learn in advance, okay, you can just click on any folder that you want here. Okay, maybe you want the more concept, you click on the more concept, you'll find 2 folders there. There's the one for the notes. Our notes has IQ Academy, and there's the one for the recorded tutorial that we've done before. Okay, so if you go for the notes there, you'll find the more concepts. You can click on them to open them. Some of them look like this. Okay, and then we have clearly stated the objectives of this lesson here. You can check out what is stoichiometry, whatever you want to do. Okay, or if you want to watch the video, you can click on recorded tutorials there, and then you click on this video here, and then you start watching. Okay, so don't feel lazy. You can actually learn, okay, on your own, because we have these things from, okay, so you've seen there, so you can watch them. Okay, if you want, you can go in the math folder. It will be the same thing. Okay, if you go in the math folder, you're still going to find something like this. So if I go in the math folder, I'll find tutorials and what. Of course, here there is no order for labs, because in math there are no labs. So Innocent, you raised your hand, you can ask. Okay, so summarize notes, tutorials, same format. Okay, so make sure you utilize this drive here. Okay, because it has a lot of materials there. So you have those topics there. If you go to functions, we have a lot: quadratic equations, cubic, sketches, whatever you want to learn. All right, so I wanted to show you that before I end the class. Thank you so much
Yeah,
for.
so
You have a question?
my question is,
Yes.
generally, so I wanted to know how can I access the film link for on your film and how to access the data?
How can you access the drive?
Yeah, your link. I don't know. So
I sent
link
the
was
link in the
online.
group. Okay, I'll reshare it. I'll reshare it in the group.
Oh, all right, thank you.
All right, so have a blessed night, guys.
Thank you, Sam.
Thank